Good afternoon and welcome to all. Thank you for joining us at DOB's first ever virtual Build Safe, Live Safe conference. I'm Gus Sarakis, First Deputy Commissioner. While we regret that the coronavirus has prevented us from holding an in-person event this year, it's also given us an opportunity to expand the number of people who can participate, and we're really pleased with the response that we received. Thanks again for your interest. I'd like to begin by thanking Buildings Commissioner Melanie LaRocca for spearheading this competition and encouraging all of us to think broadly about how we can address the most pressing issues facing the city. New York City's building code is one of the nation's oldest and most comprehensive set of rules regarding construction in both new and existing buildings. Regulations adopted by our city frequently inform model codes on the national and international levels. As our agency wraps up the code update process for 2020, we are already looking forward to the next code revision cycle. Accordingly, this summer, we launched our first ever Building Code Innovation Challenge, seeking ideas from the real estate and construction industries, as well as the general public, on practical steps that the city can take to improve the safety of buildings and workers and to modernize the construction process. With that, I'd like to congratulate our four winners, T2D2 from Thornton Tomasetti, Adjustco Anchor Thread, A Robotics Co., and CEC Elevator Sterilift. You'll be hearing a lot more from these firms in a moment. My heartiest congratulations to the winning firms. This competition was led by DOB's in-house innovation committee and a special judging panel with both public and private sector stakeholders, and chaired by the department. Our judges for the competition were Daniel Avery of the Building Owners and Managers Association of New York, Gina Bokra of DOB, Sean Brennan of the Building and Construction Trades Council of Greater New York, Ray DiDazio of the American Council of Engineering Companies of New York, Anthony Fiore of the New York City Department of Citywide Administrative Services, Jonathan Hernandez of the New York State Society of Professional Engineers, Robert Holub from DOB, Jill Rebecki of DOB, Shaji Joseph of the New York City Fire Department, John Lee representing NYSERDA, Claire Mifflin of Think Woven and the AIA New York Committee on the Environment, Patrick O'Donnell of NYC EEC, Nick Petrakis from the New York City Fire Department, Alan Price from DOB, Donald Ranchty of the Building Trades Employers Association, Zach Steinberg of the Real Estate Board of New York, Wendy Wan from DOB, and Stephen Zurinsky of the AIA New York. In addition, DOB partnered with the NYC Economic Development Corporation's Urban Tech Initiative and the Urban Tech Hub at Company to help engage startup firms as well as the city's advanced manufacturing sectors for this innovation challenge. Many, many thanks to the Tech Hub, and in particular, Robinson Hernandez and Ana Inestrias. I apologize if I mispronounced that, but I hope I was close, for their outstanding collaboration to make this day a reality. In addition, I'd like to give extra special thank you to the DOB staff whose efforts behind the scenes led us to these presentations today, namely Danielle Delahanty and Joe Soldever. With that said, let's get started. Our first speaker this afternoon will be Robinson from the Tech Hub at Company, a former DOB colleague I will not hesitate to add, who will say a few words about our collaboration for this contest. Robinson?
Thanks so much, Gus. Very excited today to partner with the Department of Buildings, the New York City Economic Development Corporation on the Building Code Tech competition. As Gus mentioned, today's a bit of a full circle for me, having worked at the Department of Buildings about 10 years ago almost, and really witnessing the growth of the role of technology in the construction industry. We at the Urban Tech Hub have been very excited to continue to support the urban tech sector in New York City. For the past 4 years, we've worked with the Economic Development Corporation, or EDC, on really supporting almost 100 tech companies in New York grow and prosper. And we do this by creating the right type of ecosystem that provides a mix of innovation, space, programming, access to corporate and government partners, and really creating community. In fact, we're working with the Department of Buildings because we're creating the city's first vertical tech campus, a building of over 1.2 million square feet of space in the heart of Manhattan that will help us to really create the ideal conditions for the tech community. But we're excited with the partnership with the city and with DOB because of their interest in facilitating and embracing new technology and helping to make New York City one of the smartest tech cities in the nation and indeed the world. We've done this in a couple of different ways. Yesterday we were working with the U.S. Department of Energy, and we're also working with small businesses, with the Department of Small Business Services, the EDC, and a number of other agencies on helping small businesses get back on their feet after the challenges presented by COVID through the Neighborhood Challenge platform. So for us, working with the Department of Buildings has been a pleasure. Working on the Carbon Neutrality Innovation Challenge, which was announced a few days ago, as well as Hack the Building Code competitions, are testaments again to the city and to the Department of Buildings' commitment to making New York safer for all of us, the residents, commuters, the workers, in making sure that we safeguard the industry in the city of New York. So I want to thank the commissioner. I want to thank you, Gus, Joseph, Danielle, Seth, the rest of the DOB team for giving us the opportunity to be part of this initiative. Want to thank the 4 companies that were selected. We're excited to hear from you today, and really in progressing the role that technology plays in New York in making it safer and more sustainable. So thanks so much, folks. And again, really excited to be part of this effort because DOB means a lot to me, having been there for several years. And I can attest to the amazing work that the DOB team has put always into its commitment to safety in New York and also into the tech competition. So thank you, Gus, and thank you to the rest of the team. Really appreciate it.
Thank you, Robinson. We really appreciate having you here today. So I'm going to turn over the control of the screen to Joseph Fugallo from Adjustco. We're going to hear a presentation from Joseph Fugallo and Jason Stile. And remember, during their presentation, if you have a question, just click that QA panel to the right of your screen. You can go ahead and ask a question there, and we'll leave a couple minutes when they're finished for them to answer your questions if they can't get to them during the presentation itself. So I'm going to turn over control of the screen to Joseph now.
Thank you. Jason, are you on?
I'd like to thank everybody, DOB, New York City, all the judges. Congratulations to the other 3 winners, and I'll be giving just a brief director of design and a co-inventor of the product. Justco started about 7 years ago with one innovation, which was a traditional power bolt. And we were able to get that product into about 12,000 retail stores worldwide, including major retailers like Home Depot, Tractor Supply, and others in Canada and Europe, New Zealand. And we realized, wow, we're an innovation company that's focused in construction and hardware. So let's continue to find solutions to issues in the field. I was an electrician in New York City for years, and a lot of the other senior people in the company all built high rises in New York City in major real estate companies, well-known ones like Cushman and Wakefield. And this innovation right here came as a solution to an issue with drilling. And I'm going to pass it over to Joey right now. This is what this is all about. This is how we're able to help New York City be safer and more efficient. So, Joey?
Great. Hello, everyone. My name is Joseph Fugallo. I'm the Director of Design for Adjustco. My father and I co-invented the anchor thread embedded anchoring system. I'm very excited to be able to present our creation to you today. Before we explain the advantages of anchor thread and how it coincides with the aim of this innovation hack, I would like to take a moment to demonstrate how the product is installed and its various applications with an animated video that I personally created. Anchor thread is a revolutionary embedded anchoring system that is designed by construction professionals for construction professionals to practically eliminate the negative effects of post-pour anchor drilling while maximizing safety and efficiency. One moment. There we go. Anchor threads are installed before concrete placement for the purpose of being available for testing and utilization immediately upon stripping the formwork. First, the lock plates are nailed to the formwork where specified. Once the lock plates are nailed, the anchor bolt assembly is inserted and tightened down. After the concrete is poured and has achieved the required strength, the forms are stripped and the recyclable polycarbonate components are removed, leaving a clean, reusable, recessed anchor point that is rated for a 5,000-pound workload and a 10,000-pound tensile strength, which makes it OSHA and ASTM compliant for such applications as fall protection, leading edge protection, safety netting, as well as mechanical systems such as sprinkler lines, plumbing, HVAC, cable management systems, ceiling systems, curtain wall, and many more. We are currently developing variations of the anchor thread to work in precast plank and wet cast applications as well. With precast plank, anchor threads located on top can be used immediately for leading edge protection and reused later for a balcony railing system, for example. The anchor threads on bottom can be quickly configured for either fall protection or mechanical systems, all the while eliminating the ground silica dust as well as the risk of drilling into the hollow cores or pretension cables, which can be a very costly mistake to correct. We offer a BIM object library to make specifying anchor thread as a connection detail quick and simple. Now that I've explained how the product is installed and how it can be used, let me relate how anchor threads coincide with the aim of this innovation hack. Implementing the anchor thread methodology practically eliminates the amount of concrete drilling operations conducted on site, which offers several tremendous efficiency and health advantages to the building owners, developers, contractors, laborers, as well as environmental benefits to neighboring residents and businesses. First and foremost, anchor threads do not produce any of the hazardous ground silica dust that is generated by concrete drilling operations. Without drilling, there's also a considerable reduction in the amount of time laborers spend working overhead on ladders, which minimizes the risk of fall-related injuries. Local residents and businesses will appreciate the reduced noise level of the construction site. With the time, labor, and materials saved with anchor threads over drilling, these resources can be better appropriated to ultimately produce projects in a safer, stronger, and more environmentally friendly manner. In every way, the anchor thread embedded anchoring system minimizes the time and risk of installing concrete anchors while maximizing safety and efficiency. Moving into the products we have in development, we'll start off with the internal anchor thread. The internal anchor thread is a two-stage female threaded cast-in-place anchor that features a 1/2" 13 thread as well as a 3/8 16 thread. Next, we have the anchor post, which is a reusable temporary leading edge protection system that bolts onto the anchor thread. Following that is the collar nut, which is a fastener used for mating substrates to the anchor thread. As you can see here, we demonstrate it being used for fall protection. There will be a visual indicator on the head of the collar nut that will change colors to inform the user that they have torqued the system to proper specification. The bushing fills the void of the escutcheon and also shouldering the load, any loads applied to the anchor thread. The anchor clip is a non-conductive, reusable hanging device for temporary lighting that clips onto the anchor thread for quick setup and teardown. I would like to take a moment to thank our early adopters, Moncon, Highbury Concrete, Ingle Berman, Pavarina McGovern, and I would also like to thank the New York City Department of Buildings for hosting this innovation hack and giving us the opportunity to present our invention. I'm happy to open the floor for any questions or comments anybody may have.
As a reminder, if you have any questions you'd like to ask, please click that Q&A panel to the right of your video and you can type in any questions there.
How do I, oh, here we go, Q&A.
We've not received any questions at this time. Here we go. We just got one. Can you please talk more in depth about the railing system you're developing?
Sure. So thank you for your interest, Brooke. So the anchor post is a temporary, I'm going to back up to that slide so you have a visual aid. So the The anchor post is a two-part assembly, or a three-part assembly, I'm sorry, that there's a base component that fills the escutcheon cavity. The collar nut, as you saw earlier, goes into that base and threadably engages to the anchor thread that's in the concrete superstructure.
Can you
And
zoom in
what's-
on that, Joey? Is that possible?
I've been trying to, in the background, figure out how to do that, but I'm unable to, unfortunately.
No worries.
Yeah. So with that, once you have the collar nut tightened down, you then insert the post, and it clips in with these two clevis pins, and then you run your aviation cable through that.
Hey, Joey, can you mention how, remember we met a gentleman that does a lot of tilt-up construction in the Midwest, and he asked us for a solution that he has a major problem to on a lot of his large job sites.
Good point. So yeah, this gentleman approached us and asked us if we could come up with a way to create a temporary leading edge system for his tilt-up wall company that would eliminate their current clamp-on leading edge system that prevented them from installing the ceiling system simultaneously, or at least immediately following the wall being tilted up. And this is what I came up with to solve that solution, or to solve that problem for him.
We have a couple more questions coming in. What kind of testing have these systems gone through, and who is qualified to install them at this stage?
Okay, yeah, so we're continuing testing because there's so many tests. The ICCES test takes a little while, maybe about another 6 months to complete. But we've done extensive testing on site. We pulled the units in columns and in the ceiling. The max load we pulled was 13,800 pounds. And the actual testing device, that was its limitation. We couldn't test it to failure, and we didn't want to actually, destroy the concrete on the site. So we're continuing to do testing to failure, but the minimum load for fall protection is 5,000 pounds, as Joy mentioned, and the leading edge protection is 200. So this product far exceeds what's currently being used. I mean, right now, companies are drilling holes and then throwing in a wedge anchor that squeezes and wedges into the concrete. Often they'll use what's the epoxy, and that has to take 24 hours to dry. And they're technically supposed to be cleaning the holes out of dust so the grip is tight. So all of those issues this eliminates having to worry about it, because this becomes a part of the superstructure. We do have engineer drawings signed off by Becker Engineering, and we did have some meetings initially with WSP. I want to give a shout out to both companies. They're fantastic engineering firms, and we'll continue to. We actually have our test results posted on our website on the Anchor Thread page, and we'll continue to release those results moving forward.
I think we have time for one more question. As a reminder, if they're not able to answer all your questions, we see quite a few coming in. Your emails will be shared with the presenters, and they can follow up with you following the presentation. So our next question is, where has your product been used in New York City, and for what applications?
Okay, so to date, we're currently installed in multiple projects on 71st in Amsterdam, around 85th in York, 34th Street and 3rd Ave, 38th Street and 11th Ave, and a few others are lined up behind that. What was the second part of the question?
And what
Applications.
Right, so right now we're just being installed for leading edge. The fall protection, we're still developing the indicator bolt, and we need to further test before the product's actually used for life safety fall protection. So mainly leading edge, and a few areas where we're tying into the ceiling for MEP applications.
Okay, great.
Which would
Thank
be
you so
pipe,
much.
sprinklers.
Oh, sorry. Okay, great. Thank you so much for sharing today. As I said, any questions that they were not able to answer will be passed along to them, or if Jason and Joseph want to, you can click on those questions in the QA panel that you didn't get to, and you can type in answers as well as the other presentations continue.
Great. Thank you, everybody. I appreciate the time and interest.
All right, great. We're going to turn this over to Akash Kancharla from A Robotics Company. Akash, I'm going to share, give you the ability to share your screen now.
Hello, my name is Akash Kancharla from a robotics company. We develop machines that are going to transform the way work is done on the exteriors of tall buildings, from cleaning to non-destructive testing to facade inspection. Today I'll be focusing on our facade inspection robot, which will dramatically reduce time, expense, improve safety, and results in adherence to local law 11. First things first, facade inspections in New York City are risky as well as inefficient. Our imaging robots are going to do these inspections faster, safer, and more effectively, and will do that at a lower cost. Presently, an engineer is going to be on a suspended gondola, somewhat similar to what is shown here. Usually they'll be accompanied by at least 2 riggers. The process is obviously expensive, it's time consuming, it takes multiple people, and it puts them directly in harm's way. On the other hand, drone-based solutions are going to introduce their own risks, being a novel platform, and they're not going to offer as much stability as gondolas. Our solution is going to combine novel robotics with time-tested mechanical elements, give innovation at minimal risk. We use multiple 4K cameras to achieve excellent clarity and much better field of view than a person could ever hope for. Our rig is aerodynamic, stable, and fast. We can handle most exterior shapes at any altitude. Engineers are going to be able to examine facades from the comfort of their office without any time pressure. Excellent for engineers who are afraid of heights. I know that there are at least some of them. To go into a bit more detail regarding some selected components here, the rig is basically split into 4 key parts. Cameras are very robust. They're 4K at least. We have options for greater resolution if needed. We also have infrared options. Our hoists are extremely powerful. Each one can safely lower the rig on its own, offering a nice level of redundancy. The pneumatic buffers and dampeners help absorb any unexpected impulse from either wind or any other external shocks. And the frame itself is extremely strong, offering well in excess of 15 times safety margin in accordance with building code regulations. Going into some of these in more detail, as mentioned, the cameras are at least 4K resolution. Depending on use cases, we can alter the field of view, we can alter the resolution, we can offer infrared and ultraviolet capabilities. Whatever the engineer feels is necessary for a given building, we can very easily pop those out, swap in another module. It takes about 5 minutes. There's not only digital stabilizers inside the camera lenses themselves, but also mechanical stabilizers, which just serve to help dissipate any unexpected gusts of wind, or if the robot were to traverse over anything from the building as well. There's both optical and digital zoom capabilities, again, well beyond what any person standing on a gondola could ever hope to achieve. We can also change complexity so that we can approach the building facade from any angle, again, depending on whatever the engineer feels is best. Talk about the hoist in a bit more detail. Adjust the line speed to, again, suit whatever the engineer recommends. We target approximately 30 feet per minute, allowing us to do a typical 25-story building in full within about 40 minutes. For our integrated AC brakes inside each hoist, these are mechanical fail-safes that are extremely robust, very well time-tested, used in all sorts of military and heavy industrial applications, and more than capable of stopping our 150-pound robot ease indefinitely. Excellent weatherproofing throughout the system, as well as heat dissipation, lets these things run practically continuously, allowing us to handle very long drops, very large buildings without interruption. There is also automated leveling and lateral line control, stable throughout the entire. The frame, as mentioned, is made up of several aluminum alloys, offering a nice strength to weight ratio, extremely aerodynamic, mostly empty space, as you can see, and we can handle gusts much beyond what we would operate, and up to 100 miles per hour will be absorbed safely by our dampeners. Also corrosion resistant, very modular. As mentioned, we can swap components in and out very easily, and it's hollow, so a lot of the core electronics are nicely protected by that aluminum as well. The buffers have a nice blend of soft rubber as well as variable density foam, and we've hollowed out the bracket on the right there, so you can see that pneumatic dampener on the inside. Basically, that serves to absorb any unexpected mechanical impulse, quickly convert that into thermal energy and dissipate it again if we get those unexpected gusts, if we have any unexpected impulse, very nicely be converted out. The rig resilience is obviously much better than any existing gondola, as well as propeller. On top of that, we offer several electronic safety checks, typically ultrasonic sensors, LiDAR. They help with the operator on the ground misestimate with their scope the extent to which things protrude. The rig can detect these, make sure that if an AC unit is sticking out too much, we're not going to run into it, as well as adjust the speed of the robot as we traverse anything unexpected. Live feed cameras are also going to give excellent field of view, both looking up as well as looking down. So you're definitely not going to, the operator ground can definitely operate very safely. Summarize some of these safety elements, again, just to be redundant and perfectly clear. The rig is very aerodynamic, it's very resilient to wind, and it's offering a lot more stability and safety than existing gondolas, as well as drones. Very lightweight at only 250 pounds per take, decently a bit less than that. The strain on the facade and the anchor points is minimized. Anchoring to the building is also a simpler process. We don't need very complex davits. We don't need very deep penetration to get an appropriate safety margin for our anchors. We have, as mentioned, those automatic safety measures in place so that human error is also further mitigated. To be redundant myself, each hoist is capable of lowering it on its own. There's also an independent safety line in place so that even if you lose both of these, which is going to happen, they are very time-tested mechanical devices, as mentioned, used in military applications, as well as much heavier circumstances than what we're using here. To summarize our core advantages, we're going to offer more thorough inspections because our visual capabilities are much better than people's. You have zoom, resolution, and stability, all three much better, and also customizable per each building. Per the engineer's recommendation. So not only can we view these recordings over and over, we can easily get multiple opinions. Engineers can reflect on recorded videos whenever they want from the comfort of their offices, second opinions from colleagues, etc. The operation itself is obviously a lot safer because no one is hanging off the side of a building. It's just the robot, the operator on the ground, is also very safely removed. We can cordon off the area so that there's really no risk to anyone involved. Not only that, but because the impulse against the building is minimized, the load on the building is minimized, we also minimize any chance of damaging that facade through our operation as well. On top of that, it is obviously cost effective and flexible as we can operate with fewer people, we can operate a lot faster. We maximize our utilization of the engineer's time by allowing them to remain in one position. They can review videos at any pace they want from anywhere. The operators can rig multiple robots very quickly. I'm by no means a specialist, and it takes me about 20 minutes to set up alone. So one can imagine an experienced rigger should be able to beat me by quite a bit. Also, by not being that heavy, it is very easy to transport. Again, I can lift it up myself. The modular pieces are very sensible. So again, 2 experienced riggers, we can expect them to complete a 25-story prop well within an hour. Give a quick sample overview of what sort of images we'd expect. The clarity, as mentioned, is excellent. Perhaps I'm not sure how the WebEx is going to render these, but these are beyond Ultra HD 4K. You can zoom more than 16 times what I'm showing you here. The WebEx might not render those very well, but we can share the image or interest. And just to give contact info, www.arobotics.company. That is the name. Thank you for your time, and thank you, DOB, for selecting.
Great. Thank you, Akash. So now, if anyone has any questions, we have time for 2 or 3 questions. Just click that QA panel to the right of the video, and you can ask him a question. What are the power demands?
I'm sorry, I'm not able to see the Q&A myself.
I'll read you the questions, don't worry.
Oh,
Stephen
all right.
asks, what are the power demands of this product?
So under maximum load, it draws about 8 amps at 125.
We have another question here. Can this system be used in tandem with ongoing repair work gondola apparatus? 1, for rig progress and methodology, and 2, video also.
Yeah, you can swap out if the existing David is in place already with the motors suitable for this application, which if you're lifting people, materials, etc., you're definitely going to have the load capacity for this rig. And yes, we swap out our hoist, we put an anchor point in place, and you can raise and lower this.
We had a question for DOB. Are any DOB permits required for the use of this equipment?
So again, this is Gus. Our answer there would be that we're going to work with the winners of, with all of the winners of this competition on the specifics of each of their processes for what it would take to be recognized for use in the city of New York. And it's going to vary from process to process. So we'll be getting back to a robotics company on the specifics of how they would go about this.
We have another question for a robotics. What is the total weight of the system?
It varies from building to building. At most, it is 240 pounds. I say varies from building to building because for taller ones, we'll lean toward that 240-pound limit simply to have more weight as we get to the bottom of the building.
We have 2 more questions that I think we have time for here. What public safety arrangements are made prior to installation?
So as mentioned, the operating procedure is relatively straightforward per DOB recommendations. The plan will be simply to cordon off an appropriate area underneath the rig. The anchor points on the roof are time tested again. They're just standard bolts driven in per an engineer's recommendation, variable per building.
All right, this is the last question we're able to get in right now, but as I said, any questions that are not answered, we can pass along to Akash following this presentation. So can the device map out locations along the facade?
So it records what it sees. We timestamp basically the altitude as well as the lateral position. So the engineer on the ground is going to know exactly where on the building any given interesting element or potential problem is.
Great, thank you very much, Akash. We're now going to turn over control of the screen to
Thank you.
Nick Gretzuk from CEC Elevator Lab Corp. Thank you again, Akash.
Thank you very much. I see.
Hold on one second. Okay, you should have control now.
Got it. Thank you. Thank you, everybody. First and foremost, I would like to thank Urban Tech Hub and the Department of Buildings and all esteemed panelists on the honor of this award. The acknowledgement truly helps validate our efforts, research, and development, and enforces us here at CEC to continue to help all in the fight against this horrible pandemic, all that come in the future, and to help our city, state, and country to heal, move forward, and progress with the knowledge that technology and industry together, hand in hand, are here to keep America safe and healthy. Our product, Sterilift, simply put, is an answer to the concerns raised of one of the most dangerous areas the public faces day to day in our cities with respect to COVID-19. Sterilift has been designed and developed to be the safest and most effective airborne infection risk mitigation system for elevators and to address the poor ventilation conditions that exist in this confined space. With current code dictating very insufficient requirements in comparison to codes and regulations in other areas of the building, such as building mechanical requirements, elevators have now become a focal point as one of the worst, if not the worst, risk areas for contamination and infectious disease transmission. This is due in part to the airborne transmission capabilities of COVID, and as current code requires very minimal ventilation and absolutely no mechanical circulation in an elevator, with the exception only of observation type elevators with glass walls that are exposed directly to sunlight. In our extensive research and development, we have designed Sterilift to address several issues. One, the creation of an actual defined circulation of air in an elevator, which is suggested of all public areas by the CDC and stressed for confined spaces. Two, the utilization of CDC recommended MERV 13 filtration to remove pathogens, particulates, and other air contaminants both prior to and after germicidal treatment. Three, utilization of specialty ozone-free UVC irradiation in a time and distance controlled chamber for germicidal treatment. Four, our care to design the system to be as safe as possible to the passengers by not adding any ozone, formaldehyde, or other toxic additives like some currently marketed systems now do. Five, seal the system from the shaftway air so as not to add shaftway impurities, VOCs, mold, mildew, or smoke from a fire condition. Six, actually remove contaminants and particulates from the cab interior air, unlike all other systems which actually could add these from the shaftway and provide no means to remove in-cab contaminants. Sterilift has been carefully designed, developed, engineered, and manufactured to be the most efficient, effective, and safest system possible in the fight of COVID, as well as any possible threats that may come in the future. Through installation now in 7 states and in multiple cities, Sterilift is working to help mitigate risks of infection from COVID and has even been tested by UL in a side-by-side comparison to a cab with only a standard typical exhaust fan. Air quality monitored data recorded by UL showed an astounding difference critical particulate matter content known as PM between the 2 subject cabs. Sterilift showed a decrease in particulate matter in a multiple data point range of PM 10 microns down to PM less than 0.3 microns of up to 97% less than that of the standard elevator exhaust fan. This test showed Sterilift's superior performance in the removal of possible viral carrying particles within an elevator. Being that a typical simple cough by an infected person can release on average approximately 450,000 airborne possible viral carrying particles, Sterilift will remove 425,000 particles from the air as compared to a standard fan shown to only remove approximately 120,000 particles. Doing some quick speculative math, that translates to a standard fan decreasing your risk of being infected by that one cough of about 30% less chance as compared to no ventilation at all, where Sterilift is a 95% less chance. And of course, that last 5%, by the way, is subject to an over 26 millijoule per square centimeter dose of UVC irradiation, which comes with 99.9% efficiency. Our intention here, simply put, is to bring awareness of the inherent risks to health and safety resulting from insufficient code with respect to current risks, development, and new regulations, and requirements to provide the riding public with safe and healthy assurances of elevator use, and to help develop guidelines and new code regulations for the design, testing, and baseline elements needed to make elevators safe and healthy again. The current pandemic, though very real, very serious, and very tragic, should serve as a reminder to us of the importance of proper guidelines of safety, public health, and code standards. We strive along with these other great innovations that were entered into this challenge and the many that will come in the future to improve upon building design, construction practices, and the day-to-day operations and maintenance of building systems to ensure the most optimal safety and health conditions for all. We do make these strides and take these steps to constantly equal code to newly developed technologies to improve upon that goal even more. The current pandemic, unfortunately, as well, has also served to define for us the consequences for inaction or ignorance of progression, innovation, and adaptations to the world and events that surround us. Our goal is to provide all that we have learned and developed to collaborate with industry manufacturers and code enforcement to not only define and implement proper changes to current lacking code requirements to ensure optimal health and safety, but also to present research and documentation to not permit currently marketed solutions that could pose dangerous risks to the public. What we do will be the results of the future. It will be our job today to lay forth the guidelines to overcome our issues for today and to prevent our failures of tomorrow. Sterilist has served to address 9 of the 11 points that were presented in this challenge. Improvement of safety along with health, identifying code regulations that need to be incorporated as well as those that need to be eliminated or revised, minimizing or eliminating particulate matter and contaminants, utilization of all properly labeled, tested, and fire-rated materials, adapting to all architectural elements as well as to existing or new installations, further development of Sterilift to an integrated cab enclosure for collaboration with all OEM elevator fabricators, improvement of customer and all public's health experiences, as well as the continued process of improvement of economical success for business, public, and government by way of minimizing lost work potential, increasing confidence in elevator use, and helping to solidify occupancies in real estate of every single type. Seamlessly designing for optimal performance with minimal aesthetic effect. And lastly, but certainly not least, the direct intention of the elimination of COVID and the continued preventative measures to stop the spread, eliminate the risk, and put us all back on a track to what will be our new normal. Thank you very, very much for your time. And once again, our sincerest and most humbled thank you for the honor of being chosen as a winner in this challenge and for the opportunity to present Sterilift to all. Now, if there's any questions.
Yes. Remember, thank you, Nick, so much. Thank you for presenting. If anyone has questions, just click that QA panel to the right of your video screen. You can type in a question. Nick, we already have one that's come in. Can you add heat or a fan to the machine above the elevator?
I'm sorry, could you repeat that question? My speaker's very low.
No problem. Can you add heat or a fan to the machine above the elevator?
I'm trying to understand, but what does he mean by the machine above the elevator?
This is Gus. I believe we're assuming they mean the Sterilift device itself.
Okay, yeah, the Sterilift is mounted on top of the elevator car. It's not for the machine room. What it's doing is it's removing the air from the elevator cab, filtering it, cleaning it, and then putting it back inside the cab for passenger.
All right, we'll wait and see if anyone else has any questions. Again, you can just click on that QA panel and type them in. All right, we have a question here. Recycling air like on an airplane. Can this be used or adapted to air travel?
Yes, it can. Right now, primarily, we're concentrating on elevators because that's pretty much what we know and what we've been around for about 30 years. But the actual filtration and technology could be adapted to pretty much any enclosed space.
We have another question here. Is the filter a standard filter?
The filters are two MERV 13 filters. We do have them custom fabricated for us by a manufacturer. However, they are readily available. There's just certain size constraints. It's 10 inches by 10 inches and 1 inch thick, but any filter will do.
We have time for one last question. Again, if you have other questions, you can type them in and we will pass them along to Nick following this presentation. So the last question for Nick today is, can the stair lift be outfitted to help with ventilation in schools and other high occupancy buildings?
Actually, we've been asked that question to a couple different venues. We are talking to a couple of schools. The answer is yes. This unit was made specifically to recycle air in an elevator. So in terms of the CFM capacity, it's made to exchange the air twice per minute in a standard 3,500-pound car. However, we can get fans pretty much any size and increase that CFM. So yes, this could be adapted to larger enclosed spaces. It could be adapted to classrooms, office spaces. It could be adapted to subway cars, pretty much any enclosed space. This was made to be very simple to put together, yet very, very effective in terms of what it does.
Great, thank you, Nick. We're now going to move on to our final presenter, Badri from Thornton Tomasetti. Badri, I'm going to turn over control of the screen to you now.
Thank you, appreciate it. I hope you can hear me.
Yes, we can hear you just fine, and you should have control of the screen now.
I'm just getting ready to share my screen. Yeah, I hope you can see the screen now. So good afternoon. We're delighted to be recognized as one of the winners of the Hack the Building Code Innovation Contest.
Badri, sorry to interrupt you, but we do not see anything on the screen right now. It's a blank screen.
Is that any better?
That's it. That's great. Thank you.
Okay, great. Thank you. So yes, through this challenge, the New York City Department of Buildings has started an excellent initiative to modernize the city building codes to accept cutting-edge technologies that can enhance the safety and efficiency of the prescriptive process. And we present to you T2D2 and demonstrate its use of AI and computer vision technology to transform the facade inspection process and make it safer and more cost-efficient. And before we move on, just a quick introduction of myself. I am a VP and Director of AI at Thornton Tomasetti, and I'm also the founder and CEO of T2D2.ai. It's a spin-off that came from the TT Innovation Lab. So the primary objective of current regulations surrounding building facade inspections is to ensure public safety. That's the number one goal. That's to prevent falling pieces of facade, injuring people on the ground, and so on. So can we achieve this objective of ensuring public safety, even enhancing public safety, while at the same time making the process more cost and time efficient? As some of the other entries have already shown quite impressively, the answer is yes. Drones and technologies can be effectively deployed to virtually inspect large building envelopes and quickly and easily collect vast amounts of data about the state of facades and structures. But how do we convert all that data into information and that information into insight about the state of the facade? This is where T2D2 comes in. We present T2D2, the Thornton Tomasetti Damage Detector. Over the last few years, computer vision technology has made tremendous strides, achieving better than human performance in several benchmark studies. This has led to wide adoption in various industries, including consumer technologies, security, and even medical diagnosis. through T2D2, we bring the same technology to the AEC industry. We've deployed state-of-the-art computer vision models, which is a narrow form of AI powered by deep learning, to automatically detect damage and deterioration from image and video feeds. TT has been inspecting buildings through its renewal and forensics practices for many decades and has a large collection of photographs showing various forms of damage and deterioration in structures. The T2D2 computer vision models have been trained on these datasets that are carefully annotated by our experts. T2D2 has been deployed to process images taken by drones, as well as mobile devices and other traditional cameras. So how does it work and what's under the hood? T2D2 is not just a single monolithic damage detection model, but instead it consists of a pipeline of various models built using machine learning. Some of these models are a binary segmentation classifier that extracts the structure portion of the image from its background, a proximity classifier and a gridding tool that virtually zooms in on high-resolution images taken from a distance. The material classifier identifies the substrate material, such as brick masonry, concrete, steel, glass curtain wall, stucco, and so on. And we have different damage detection modules that are specifically trained for these different substrate materials. So depending on the material classification, the core damage detection modules will identify various types of damage conditions that are specific to those materials. For example, cracked mortar joints in brick masonry, spalling with exposed rebar in concrete, corrosion in steel structures, and so on. The output stream is composed back from its original size from the gridded sub-images and then handed over to downstream functions such as generating reports and so on. Photogrammetry is routinely used on drone feeds to build 3D interactive photorealistic models. The T2D2 can process these same image frames to identify damage conditions, and in the process, these 3D models can be geotagged with the T2D2 damage conditions. We can also geotag 2D orthomosaics. These are photo stitches composed from hundreds of sub-images that are aligned and stitched together. And in this case, the damage detection is done using a sliding window approach. While T2D2 is smart and can identify a lot of defects, it is, of course, not perfect, not at this time anyway. It too makes mistakes, sometimes flagging a stray tree branch or wires as cracks, or sometimes misflagging some conditions. So we have a team of engineers review the photographs and detections, and they mark up the false positives and false negatives. These corrections are then fed back into our training database so that the system can learn from these mistakes and then get better over time. And we have a way of tracking, we have various metrics that we keep tracking over time to see how the models are performing. The T2D2 online portal serves as a repository to host the digital twins of these building envelopes. As photo inspections are repeated for a structure, the portal can track how damage conditions at specific locations evolve over time. In some cases, they may also provide early warnings so that certain conditions are developing that may be easy to fix at an early stage instead of developing into costly or potentially unsafe and dangerous condition if they're ignored. So in summary, T2D2 brings the latest digital technologies to bear to transform the building facade inspection process while also promising to enhance public safety and increase efficiency. If you have any questions, please visit our website or reach out to me. The email is info@t2d2.ai. I can be reached at my Thornton Tomasetti email as well. That's bhirur@thorntontomasetti.com. Thank you very much.
Thank you for sharing. We have time for a few questions. So again, just click that QA panel to the right of your screen, and you can type in any questions there.
I see one question. When do you think drones will be allowed to be used in NYC? I think that's a larger question for buildings. I know that there are many people within the agency and around the city who are evaluating various laws and about how they would be and the measures that would be taken to allow drones to be flown in the city. We have also participated in various efforts to show we've been using drones through our partners in various other cities, and we've also co-authored a white paper about how it can be useful. But that's a question, of course, for the larger community. Will this system be compatible with the robotics camera system? I certainly hope so. Yes, we've not worked together, and it looks like the robotics company generates a lot of high-resolution images that cover the entire structure, and I think T2D2 can be a perfect partnering tool to identify the damage conditions from images taken from that system.
This is Gus. This is Gus from the Department of Buildings. I want to follow up on the question of when will drones be allowed for use in the city. I think that is a bigger question than just the Department of Buildings. There are other agencies and levels of government that need to get involved on that level, but we are, of course, working with everyone to do our part there. Our aim is, of course, safety of the public and ensuring safety of buildings and structures in the city. And we're open to using tools to advance that process. So we look forward to continuing to work with many stakeholders to advance safety.
We have another question here. Are there any limitations to heights or wind resistance you experience? Can images be combined with other technologies?
Sure. For the first question, I should say, so we are mainly in the or the data processing side of the stream. The image collection can be through drones if they're allowed, or through other means, through the robotics company or other means. So I think the condition about wind resistance and the heights are related mostly about the data acquisition. We are further downstream where we process all of the images and detect conditions. In terms of combining with other technologies, yes, certainly. I mean, we can. We are right now processing RGB traditional images, but we are also processing thermal images, thermography images to identify anomalies right now from a sustainability perspective to identify thermal leaks and so on, but eventually they can also be used to identify structural conditions. And we are also looking into the use of point clouds from LiDARs for detection of damage conditions, if they can be used.
We have another question here. I'll read it verbatim. What percentage of false readings have you come across by use of this system? By the way, this is awesome. Many props.
Thank you so much. So the number of false positives, there are quite a few false positives. I cannot give you the exact metric because they're all dependent on different modules. Like I said, T2D2 is not just one monolithic model, but we have a series of different modules, and each of those modules have various false positive rates and false negative rates. In fact, we track various metrics related to computer vision, and these we use object detection modules and semantic segmentation modules. So the actual metrics are quite different. They use something called the dice ratio and precision and recall, average precision and recall, which we track over time. And I can give you, if you reach out to me on my email info@t2d2.ai, we can go into details about the exact metrics for each of the submodules that we have.
We have time for one or two more questions. One question here, is this a drone hardware company or software company?
We are a software company, and we partner with drone providers. We provide, when I say software company, I shouldn't say we are strictly a software company. We've developed software and we built on a software, but we're a service company. We service. We provide our services to building owners, facility managers, and provide an end-to-end service. And for the drone image collection, we partner with, with third party. We have a trusted partnership with a company called Helios Visions out of Chicago, who have a lot of, waivers and special permissions, and they have a lot of experience in flying drones. We would partner with these data collection companies, and we process those images and present we also have engineers who will review the detected conditions and provide annotations to provide more feedback on what exactly we're seeing in an image. What is maybe the models detected some crack, but an engineer can add some insight into what is the nature of that crack. Is that something that is mild that can be safely ignored, or if that is something that has to be immediately corrected? So we provide an end-to-end service that is built on a software.
Great. Thank you so much for presenting today. I'm going to turn this over to Gus, who will wrap up the presentations today.
Thank you to all. Those were some fascinating efforts to improve the safety of our city's buildings. It was a real pleasure to work on this effort and to see firsthand how our city's innovators are bringing their creativity to bear on improving our city of more than 1 million buildings and counting. I hope you enjoyed the presentations as much as we did here at DOB. Thanks again to our winners for submitting their ideas for making our city safer for residents, workers, and visitors alike. And to the audience, thank you once again for joining us. I'd also like to give a big thank you to both Seth Stein here and John Lee from our, Seth from our press office, John Lee from Buildings University here at the Department of Buildings, for not only this wonderful presentation today, but for all of the presentations during this week of the 2020 Digital Safety Innovation and Sustainability Conference. For those of you who were able to participate, I hope you enjoyed those also as much as I did. For the licensed professionals, please keep this in mind. This was a really good way to get a lot of continuing education credits for the year that we all offered here at the Department of Buildings for free, and hopefully it helps you navigate the waters of how to do work safely and compliantly here in the city of New York. With that, thank you very much all, and hope to see you again very soon on one of these webinars. Be safe.